Well, welcome to This Might Sting. I'm Julie McCrossan, and today it's the science of healthy eating with practical advice. And along with my comrade, Dr. Aidan, we're welcoming all the way from California, Dr. Kevin Klatt, who's a research scientist at the University of Berkeley in California, a registered dietitian, a metabolism researcher, and I think it's fair to say, Kevin, you have a really passionate commitment to evidence-based public education and information. It's so great to link with you across cyberspace. Just to begin, what is metabolism for our general audience, and what's its relationship to healthy eating, and why the general people with an interest in health need to understand it a bit?
Yeah, so the root of the word metabolism kind of means to change. I think it's Greek, don't quote me on that, but it describes how our body interconverts compounds into one another so that we can get all the things we need. And so we eat food kind of as the raw material, our digestive tracts break it down, and then our bodies, quote unquote, metabolize it. And so that is how it takes what was the form that was in the plant or the animal that you're eating and changes it into all the things that it needs. And then alongside that, all of those chemical reactions that are interconverting compounds into each other, there is either the need for energy or the release of energy in those processes. And so we think of bioenergetics as tightly coupled into this process of metabolism. For someone like me, I think it's a very simple thing of I want to know what goes in, what your body does with it to take it apart, and how it gets put back together into whatever the body wants it to do. And you can think of it as that very high level and then get really down into what organs are playing which roles and breaking down which compounds, and even further what cell types are doing that. And then even at the level of the cell, like what parts of the cell, the endoplasmic reticulum, the mitochondria, where is that compound being broken down or put back together? And so you can look at metabolism from the little microarchitecture of the cell all the way up to the whole body and the human being. So when we say metabolism, I think most people think weight loss, but that's really just referring to that bioenergetic side of things. It really is just referring to this breaking down and building up of, you sometimes hear it called anabolism and catabolism for the building up and breaking down sides of metabolism.
Look, a bit later, I'd like to talk to you about some practical advice in relation to the prevention or reduction of some of our chronic illnesses. But let me open to Dr. Aidan to follow up some of the science and research issues. Thank you.
Look, I'm so stoked to have you on the podcast today, Kevin. So everyone knows I'm a huge fan of Kevin's and have been quite a fan for a while online. He is seriously committed to evidence-based statements and really excellent research. And this is such a nutrition and food and what we eat is such a massive industry, and the myth and dogma that's purported around social media is so common. Every day I jump on Instagram and I am bombarded with essentially non-truths about what I should be eating, what I should be putting in my body. And so it's been so refreshing the past few years to see Kevin have this consistent commitment to high quality research. And I was reading Kevin's Substack recently, and he wrote this fantastic article on the keto diet. And I've been following the keto diet journey for a while. For those of you who haven't heard of the keto diet, my rudimentary understanding is basically it's about eating a high fat, moderate protein, very low sugar diet so that you're essentially in what we call ketosis. So you're not, and this is the basic model here, and I'm going to get it wrong, and Kevin's going to correct me afterwards, hopefully. The basic model of ketosis is sugar is essentially, we need sugar as a source of energy, and we break down sugar to create energy, but it causes a lot of issues. And sugar is basically the reason we have a lot of our chronic diseases. So if we can break down fat for energy instead of sugar, that will somehow make us healthier, and it will make us develop less plaques in our arteries. It will make us develop less diabetes, and it will be the solution to all our woes. So I absolutely loved this really eviscerating takedown of the overclaims that some of the keto diet proponents have. Kevin, can you explain to me, what is actually the keto diet? What should I know about? And is it the solution to all my problems?
Yeah, okay. So the keto diet goes back in history and starts out as a treatment for epilepsy. And so particularly before there were mainline drugs for epilepsy, but even after that, folks were looking for ways to control seizures before you had pharmacological therapy. And so it was noted that fasting which induces a small period of ketosis. But obviously, you can't fast for forever. You would lose too much body weight and start catabolizing your organs, and that would be bad. So that's not a long-term solution. But it was noted that during fasting, you start to make ketone bodies that appear in the urine, and then early researchers started testing if you fed, as you said, a high-fat diet that is relatively modest in protein, really just like right at the amount that we think is the requirement, and then very low in carbohydrates, that you can cause the body to shift its preferred fuel source. So your body's always making a ton of glucose and trying to keep that glucose level quite tight within the bloodstream so that there's adequate amounts for all your organs to use it. So it's this constant flux of you eat some glucose, your liver makes some glucose, and your peripheral tissues and brain are all utilizing that glucose and trying to keep the level in the blood at a certain level, a certain minimum, to fuel all those processes. But when you eat a very low carbohydrate diet, your body still maintains a certain amount of blood glucose through a process called gluconeogenesis, where you turn things like amino acids into glucose and fuel, and just enough glucose for things like red blood cells and parts of the brain that really are obligate users of glucose. But then body starts to break down fats and they build up into ketone bodies. And then your body all the organs can start to pick up those ketone bodies and start to use them to break down into energy rather than using glucose to break down into energy. And so for mechanisms we don't fully understand, this helps with seizure control. It's probably at least due in part to the breakdown of glucose, which we call glycolysis. It very rapidly generates energy and allows neurons to fire, and the breakdown of fat is a little bit slower. So those neurons that would otherwise seize are rate limited, at least to some degree, in their ability to seize by the slower pace of energy production. And people think there are other mechanisms. The ketogenic diet and being in ketosis might limit seizures, but beyond that, like the physiology of it is that your body is just shifting its fuel preference away from glucose, and so you have a very low, physiologically, a very low insulin levels, and you get a little bit of a bump in glucagon, which is a major hormone that is allowing you to make your own glucose a little bit more. And then you have that breakdown of fat that it really is. I mean, we could go into intense biochemistry here and back to the Krebs cycle and things, but essentially the liver is oxidizing lots of fat and then making ketone bodies out of acetyl-CoA that's building up. And then you get those ketone bodies going out to other organs to use for energy. And that therapy in epilepsy and just the general molecular study of ketones and what they're doing has led to all sorts of theoretical uses for the ketogenic diet in other places. And there's not a lot of, you can imagine it's very hard to do these studies. So I should say clinically, we rely on what is called the ketogenic ratio. We typically use a 4-to-1 ratio. So that means it's 4 grams of fat to every 1 gram of carb plus protein. And it's usually higher on the protein to meet basic requirements and low on the carb. So this leads to about 80 to 90% of your calories coming from fat, and then just about 8% of energy typically coming from protein, and minimal coming from carb, to just very residual amounts of carbs that are in foods. So that's very hard to do. We often clinically rely on formulas that are like very rich in fats. Because even if you sit down and do what dietitians do, where we have menu planning softwares that take into account nutrition facts, getting carbs that low, even on a natural foods diet, is extremely difficult. There's a lot of butter involved, typically.
Even just eating steak and chicken, and if I just ate animal meats and nothing else, I'd still struggle to actually get to that ratio, right?
Yeah, so the traditional ketogenic diet is actually quite restricted in protein. So some of the amino acids are able to be turned into glucose and fuel the Krebs cycle. And so that limits the degree of ketosis a little bit. They also can stimulate the secretion of insulin, which suppresses ketosis. And so a lot of the initial work, they always limited protein. And then even in animal work, you see this, because in animal work, you can do a whole bunch more of a dose response relationships. I mean, you can see in rodents, when you really restrict protein, you get ketones to go even higher.
I just have to come in because as someone who stopped science before the end of high school, I'm left thinking, is the ketone diet a good idea or not? Just what's our fundamental message, Kevin, about this diet, but I guess about specific diets in general, because I guess I'm keen to go to fundamental principles of good eating. But first of all, is this diet of any use to anyone other than epileptics?
Well, so that is the area where it is a tried and true treatment where often there's not a drug. And so keto diets for many other reasons, you could argue are therapeutic. But I think it's important to mention when we say a keto diet, that tells you nothing about the overall quality of the diet, whether it's providing essential micronutrients, the type of fat that's in it, which we know fat composition is a determinant of your blood cholesterol levels. And so anytime, I think if viewers walk away from this, anytime you have these named diets, they often have lofty guardrails that they'll fall within, but it doesn't really tell you the specifics. You can do a quite carbohydrate restricted diet that still contains a lot of low starch plants and a lot of avocado and nuts and seeds that will be tough to get down to a super strict keto diet, but it's still heavily reducing carbs that it might help you lose some weight and isn't going to maybe have as bad of an effect on your LDL cholesterol, for example. And then you can do the keto diet that's 80% butter, which I think we would say is not so great for you and probably is going to spike most people's cholesterol. And so there's always nuance with these things, and it really matters how you formulate the diet. And I think everyone, when they hear a diet, they should say, like, you can just do the same thing with the low-fat diet. You can design a low-fat diet that is high in refined grains and added sugars, and really high energy density, hyper-processed foods, or you can do a low-fat diet that is whole grains, beans, dark leafy greens, fruits. And so that name almost doesn't tell you anything at some point. It just gives you one macronutrient it gives you one tree and you can't see the forest. And so you really have to ask a whole bunch more questions.
I guess I'm interested in, from both of you really, in whether there is merit in the intense focusing on any particular quirky diet that's being promoted on social media. At all. And I ask that question because in another part of my life, I've been hosting discussions about all manner of health issues for a hospital with a sort of public webinar. And there doesn't seem to be a health condition for which exercise and a good basic healthy diet aren't a good idea. And so it leaves me wondering if we should be talking about the fundamentals of a good basic healthy diet. But am I wrong? Are there particular diets that are of use in particular circumstances? And if so, should we approach them without the help of a professional dietitian?
Yeah, so I think that's what the dietary guidelines are really trying to do is give targets and basic overviews of choosing fruits, like focusing on food groups, getting a certain number per day from different food groups, focusing on lean proteins, a few servings of dairy. I haven't looked at the Australian dietary guidelines in a minute, but I think it's relatively similar to the US. There's quite a convergence across all of them. But they give those general, like focusing on food groups that if you kind of aim for these things in general, you don't have to get hyper prescriptive, that you'd be able to have a relatively healthy diet at the end of the day. I think some individuals, certain diets might work for them a little bit more. They enjoy trying out specific diets. They need a little bit. There's some people don't respond well to like restrictive guidance. And then I think other people like that and need those guardrails or benefit from them. So when it gets to the individual level, I think that's where it is very helpful to just chat with a dietitian. If the general advice isn't working for you, then that's maybe the time to take the next step and go see someone to help individualize things. And I always tell folks, like, nutrition, it's not, gate kept behind a prescription pad, and the evidence is rarely prescriptive. And so there's a lot of things that you can try and optimize to figure out what works for you. And I think often what frustrates people is they're looking for a prescription, and it's inherently not a prescriptive science in most cases until you have like severe inborn errors of metabolism and things where it's like you cannot eat more than this amount of phenylalanine if you have PKU. And so they're quite disastrous situations when we're giving really strict prescriptions. But you can meet all the essential nutrients and control chronic disease risk factors for the most part through many different ways. And particularly, I think most people are thinking about the control of obesity and maintaining a lower body fatness. And we have low carb trials, low fat trials, Mediterranean diet trials. And for the most part, the thing that sticks to it comes out is like whatever you can adhere to best that helps you maintain a healthy body weight is ideal. There's no research that supports like a magical metabolic mechanism at this point. And everyone will cite that on social media. And they will cling to no ketones, suppress your body weight. They activate the NLRP3 inflammasome and fight inflammation that's driving obesity and chronic disease and all that sexy sounding language. But I could sit here and do that for every macronutrient, for every single thing in food, for every diet. just cite off all these mechanisms, and that's totally ignorant of the clinical trial data that shows that there's a wide variability in how people respond to them within a diet and also between diets. And so when you look at 12-month data from people randomized to, and even 6-month data from people randomized to diets that are uber low fat all the way to uber low carb, they all follow the basic principles of energy balance, and they all can be designed in ways that are, for the most part, otherwise healthy. Some of them are easier to skew and mess up than others. But yeah, I think if you're deviating from the general dietary guidelines that are out there, you should chat with a dietitian, work it out to find the diet that works for you, and make sure you're not like steering yourself in any wrong direction. I think there is a lot of people who are just like, I'm going to go start the carnivore diet because some influencer told me to. And those are the diets where you get into it much easier to screw it up, because you're eliminating virtually all food groups apart from a couple, and you can run into problems there. And I think that's what I see increasingly in my clinic is people referred to me who are like, they've 2 years into their wellness journey and all their labs are messed up and they're on dozen supplements and they're trying these interesting diets, and the clinicians or physicians are like referring them because like, we don't even know where to start, like what could be the problem. And I like to help people optimize their diet for prevention, not correct a bunch of metabolic challenges that they've induced upon themselves, ideally.
So can I ask, you mentioned people getting into real danger territory, and you also talked about micronutrients. For those of us who are listening who have no idea what a micronutrient is, can you basically explain what are essential nutrients, what are micronutrients, or even essential amino acids, and why that matters, why having a balanced diet matters, and what the dangers are when people go into these crazy restrictive diets, which are hyper specific?
Yeah, so micronutrients are typically referring to the vitamins and minerals in the diet that are essential. That word gets a little bit flexibly used sometimes to refer to like bioactive components that are technically not essential, but for the most part, they refer to the vitamins and the minerals. Minerals have important signaling roles in the body. They're how cells communicate with each other. They're also important structural component of like your bones, so calcium, obviously, or iron, which helps in heme formation. And so there's those minerals and there's vitamins. Often they're like, a lot of them are cofactors for enzymes. So for the enzyme to work properly, you need that vitamin. And for the most part, a generally healthy diet provides the adequate amounts, what we think are adequate amounts of all of them. Often, I should be clear, there's limited data. It's very hard to understand like what is the true nutrient requirement for vitamin B6 or whatever. And a lot of times if you dig deep into like how we derive the reference values that we set there, either based on 1 to 2 studies or there's a lot of guessing involved. And so fund nutrition research so we can get better data. It's always a pulpit that I am on, but for the most part, we can definitely prevent nutritional deficiencies. And for the most part, we think optimize physiological function with just eating a relatively healthy diet. There are medical conditions where supplementation is definitely needed. But when you start to cut out individual food groups that end up being major contributors of some of those essential nutrients, you run the risk of running low. And it doesn't mean that every single person who starts the diet is going to be low. It's more of a probabilistic thing that your risk might start to increase. If you are somebody who, we think of nutrient requirements as a distribution, and if you're on the high end of that distribution requirement and you suddenly start dropping to really low intakes, over time, your body's stores of them start to be depleted, and then physiological processes get compromised to some degree. And that can manifest in various ways, often very non-specific ways, like just fatigue or mental fogginess, which, I mean, just existing in 2025 comes with those things in general. And then you get more specific symptoms often as you get more and more low on that nutrient. And so we're eating enough to make sure that our body has enough in its cells to do the things that it needs to do. It's often extremely hard. There's not great blood tests you can measure to figure out. Usually if a blood nutrient level is low for most of them, it is by the time point where you're really depleted. And so it's hard to detect what we call like a subclinical deficiency, where the blood marker is not changed yet, but you're starting to experience symptoms because that a specific organ starts to be stressed by not having enough. And so That's my pitch for having a well-rounded diet, just to make sure that you're getting enough of everything, because the symptoms can be super non-specific and hard to pick up clinically. If somebody comes to your clinic and it's, yeah, I have all these symptoms, I'm like, that is the symptoms of 12 nutrient deficiencies, but I can't say which one it is, if it's even any of them, or just because you're really stressed in your life. And so we are often in nutrition triangulating across what we can tell from your blood values on everything that a physician's used to seeing, and maybe some extra tests there, what your self-reported dietary intake is, and dietitians do really deep, thorough diet histories on that, what your body weight and other anthropometric values are. So it's a lot of triangulating across super imperfect indicators to try and put the picture together and then plan a diet around that.
Can I just ask you, I'm holding up the one that I do take, which is vitamin D, even though there's a lot of sun in Australia. As I listen to you, I'm aware that when I go into a chemist or a pharmacy, there's just walls of supplements. And we're talking about, are we getting enough of the nutrients, micronutrients you've just been explaining? What is the evidence in relation to when or if we should use supplements? And I'm particularly interested because so many people these days are using injectable medications to lose weight. And some of those people I know are using a huge amount of supplements and not much oral food. And I'm just wondering, are there risks involved with that as well?
Yeah. So there are definitely clinical indications for this. There are specific symptoms, particularly things that cause malabsorption or impact the GI tract, where you might have enough in the food, but your body's not actually taking it in. And so that can become a problem. Or like things like as you get older, the incidence of like having low gastric acid starts to increase. And so you might malabsorb things like iron and B12. And so in older adults, that might be more commonly recommended. There are situations like being vegan, where vitamin B12 is absent from your diet. So that would be recommended. I think supplementation, it's really important to think about supplement was sort of originally planned to be like filling a gap that's in the diet, or providing enough so that you can have enough in your body because your diet isn't giving you enough of it, or you have impaired absorptive capacity. And so you have to give like 10 to 100 times the amount that you would normally get in the diet just to get a little bit in. And so those are the roles of nutrient supplementation. But the class of supplements has expanded to include probiotics, herbal extracts, and everything. So people want to make a broad claim about supplements, but that's like trying to make a broad claim about nutrients. They're all different. And so I think the point of classical nutritional supplements is to fill a void or fill a gap where one might exist. But we've also gotten into supplements that are trying to make close to medical claims of this herb or this extract is going to help with your depression or mood or hormone levels or things. And that's, in America, we have an FTC that couldn't possibly regulate the amount of influencers that are out there given its budget who are making medicalized claims. So I do think it's really important to separate that kind of thing out, where there's many classes of supplementation. But dietitians will regularly, you might have a lab value that's particularly off, that with vitamin D that you just held up there, there's target blood levels that we typically don't want to fall below. And so someone might recommend a vitamin D supplement, and the vitamin D supplement industry has gotten really out of control, and there's big fights among scientists over what the ideal and optimal blood levels are. And those fights could mean either nobody needs supplementation apart from a small subset of the population, or everybody needs them. And so we've had about 10 years now of a massive vitamin D testing and supplement industry. And it's really just capitalizing on uncertainty within the data and what that optimal blood level should be. In general, there's no randomized control trials that show attaining these super high level blood levels that some people are advocating for all that beneficial. And that's when you would need to take mega dose supplements. And so the cart got out before the horse. I don't know if you guys have that saying, but it definitely got out before the horse. And now we have this massive multi-billion-dollar vitamin D testing and supplementation industry. And so you can see how these things intertwine with capitalism a little bit to really make a bunch of people a bunch of money without clearly impacting our health. But this is the important point of being evidence-based and really being advocates for funding research.
And I love that you've spoken to the fact that supplements were originally intended to fill a gap. And actually, the way that we're using them now is not to fill a gap that we've gone, oh gosh, I'm lacking in this. It's actually to go, I want to be super healthy. If I take more supplements, I'll be more healthy. And what's interesting is in Australia, we've actually seen a bunch of toxic levels of vitamin B6 in particular causing neuropathies. Neuro meaning nerve and pathos meaning disease. So neuropathy, disease nerves, people start lacking sensation and feeling because they're accidentally getting supra, i.e. more than the therapeutic levels of vitamin B6, significantly more to toxic levels, because it often is put in magnesium supplements in Australia. And so we're starting to see this huge, when I say huge, the people aren't lining up every day, but multiple cases now in most large cities of people coming to their doctors going, Doc, I'm losing sensation in my hands, I'm getting tingling, I can't feel my socks anymore. And they're getting these incredible distributive neuropathies from super high levels of vitamin B6, which they didn't even know they were taking because they've been added to supplements. And it's so interesting to hear that there's no evidence to support us taking all these supplements if we're eating a healthy, balanced diet and we don't have any specific deficits. It's reassuring.
Yeah, these things often there's a lot of the misinformation in nutrition comes back to somebody coming up with a hypothesis that never really gets tested, and then people just acting on the hypothesis. There was a hypothesis a long time ago that our cells can actually take up so much more B vitamins, and maybe the levels in the foods are too low nowadays the way they used to be. And so we need to take these megadose supplements to saturate all our enzymes with that vitamin cofactor so they work optimally. And that sounds cool. It sounds great. It would convince a lot. This was back in the pre-influencer days. If you went on Instagram Live and said that now, you'd probably get everyone running out and buying supplements saying that. But it's just a theory. You have to test that theory in clinical trials and say, when I give high doses of these supplements to people, do I see benefit and do I see potential for harm? And in most cases, what is people pee them out in their urine because it's more than their body wants. There's a jokey meme I posted one time of my body's a machine that turns expensive supplements into expensive urine. And I think it's a lot of times true. I also do think there's a new concern. So there's like a report that I just saw circulating in the American media about acute liver injuries. So like they're documented when people enter the ER. And so those are a huge fraction of the time they report on kind of the intake form that they've been taking herbal supplements. And our bodies are exquisitely designed to see all the thousands of chemicals that are in plants that we're eating, and they see them as like toxins, but our livers are well adapted to excreting them, basically metabolizing them and excreting them. And there's some thought that very low levels might actually be beneficial. It's like exercise where it's an initial stressor, but then the adaptation response is better. We call it hormesis. That some of the other compounds that are in plants might be beneficial through that sort of approach. But then people take that, they remove the dose component, and they assume I need to take huge doses of this in supplement form. And they're just low level toxins that now you're taking super high levels of. And it's not surprising that they can cause some issues. And there's a lot of these green tea extracts that are also not standardized in their dosing. So there's lot to lot variability, and you might be getting way more than you thought you were getting. So it depends on how reputable the supplement brand is and things. But people are taking these with no clear clinical indication. There's often wellness relies on vagaries, I think, where this is good for your microbiome or your general health, and like these non-specific terms that they sell you based off of. But like you say, microbiome, like how do you even define what a good microbiome is? Show me the studies where microbiome is like a meaningful health outcome. But people, on the influencer space, they're not relying on clinical trials with meaningful health outcomes to guide their responses. They're relying on what they have an affiliate code for that gives them 25% back.
Could I come to this issue of the commercialization of big food, like we used to talk about big tobacco? Because this emphasis on a good quality but balanced diet, following the food guidelines our governments pump out, it's a problem if you're poor. It's a problem if you're in what's called a food desert, where access to healthy food is hard. And it's also a problem, the boxes of breakfast cereal, just to use one example, have got additives in them that are insufficiently controlled by government regulation. So I guess I was wondering if you could give us some insight into that it's not just about individual decision making, is it? That how much money you've got and where you live are critical factors in our capacity to have a healthy diet.
Oh, absolutely. I think the easiest, lowest hanging fruit example of this is like you can't control whether there are pathogens in your food. If your food's contaminated with E. coli or listeria or salmonella, like you can't look at a food and immediately tell that. And so it's a perfect example of how we need regulations on industry to be doing things that control the potential for contamination. And that's not an individual level choice, but it makes hundreds of thousands of people sick every single year. And so when you move beyond just the sort of microorganism side of things into the amount of added sugars that are allowed, highly palatable, high energy density foods that are full of added sugar and sodium, a lot of that you don't have control over the composition of foods. And I think that's increasingly, like, we see a lot less food being made at home. There's not even home economics classes all that much anymore. So it's not guaranteed that the food you'd be making at home would be all that. It might still be from a box that you didn't have control over what went into the recipe, but we're often eating out a lot more takeaway and restaurant type foods where I don't have control over the sodium. You might think you would be able to just taste super salty things, but your body habituates to the level of salt that is in the foods. And then, competing taste and flavor profiles can make you more or less perceive the saltiness of it. So there's some things people eat. Like, most people don't think of bread as all that salty, but it's an extremely salty product and a major contributor of salt in the American diet, at least. And same with things like salad dressings and other condiments. And that's all things that are put into foods for some degree flavor, also some degree the preservative action, but you don't really have much control over that. And so you could go through and walk through the entire food system, from the way foods are formulated to additives to microorganisms and foodborne illness risk, where I think there's a strong case for some level of regulation to ultimately ensure that the food is safe. And in America, I can say we've done a much better job on the microorganism side of things. And now there's a lot of calls right now. We need to do more on the chronic disease side of things. But obviously there's industries, and every single food policy is intrinsically political because it is regulating a massive part of the economy. And so there's always political pushback.
Are there one or two key priorities you would put on that sort of systemic advocacy? I was wondering about things like, here in Australia, there's been a lot of talk about what is sold in what we call tuck shops at our schools, but the food that you get at schools, or indeed the education that you get about cooking. What do you think are one or two things that really could make a kind of community-wide difference when it comes to the next generation and eating?
Yeah, we similarly here have a big focus on federal programs around school lunches, as well as the supplemental food packages that are given for people who are lower income, including the Women, Infant, Children's program. And so there's big debates going on now about how we incentivize purchasing of healthier foods and also address things like you can require that people buy some amount of fruits and vegetables with their supplemental nutrition assistance programs money. But if there's not fruits and vegetables nearby, it's very hard to buy. And so you need, I think, you have to really look across the entire food and agricultural value chain and what consumers are interfacing with, and think about, I think, multi-pronged interventions that not only allow you to buy fruits and vegetables, but ensure that they're accessible. And I think, like, you need to have programs that not only increase fruits and vegetables in the school lunch, but also pay for chefs who know how to cook foods that kids will actually eat. And so often you'll hear one thing that people get behind, and that in and of itself is not, it creates as many problems as it starts to solve. And so you need these multi-pronged society-wide interventions. But I do think there's some policy levers around, particularly in America. A big one is it's still voluntary, but sodium reduction targets adopted by the food industry, because we're still more than a gram of sodium intake over what the sort of levels that we think where chronic disease risk really starts to increase. And there hasn't been as much progress on it. And part of that is the preservative action of sodium. And so you also need to stimulate research into alternative preservatives that are not perceived as scary sounding chemicals to consumers and are safe, and also get that sodium down. And so this is, again, it's really hard for me to think of one point of where you intervene in the policy agenda, because you then got to go look up and downstream of that and make sure that the policy you instituted can actually happen, and then it's not causing a downstream issue.
I just asked, do you have a particular interest in pregnancy and how you can help pregnant women?
Yeah, that's what a lot of my research has been in.
And so what's your key message there for, obviously, our women listeners about the critical nature of nutrition in pregnancy?
It is critical. I do think pregnancy is a time that can be very stressful for a lot of women, and they can sometimes go the opposite end, where they think that every single thing that they do is a potential catastrophic event. And so I don't want to also oversell nutrition, but nutrition during pregnancy is an extremely important time where what you're eating and what you're exposed to in the environment can impact the developing fetus whose their organs are still developing, even how their DNA is going to be expressed later in life, things like epigenetics. We're still learning a lot about this, but we think having a relatively healthy, diversified diet is pretty important. And so, as well as having like being particularly mindful about food safety type things. So foodborne illness risk increases in pregnancy. And so I think a few tweaks. I'm a big fan. I wish we had better coverage of dietitian visits for pregnant folks. I think everybody who's pregnant should get access to one visit with a dietitian to go over, all right, these are the high level foodborne illness things. This is what to think about in key nutrients that are often you run low on, things like iron. A lot of the work I've done is on choline supplementation, which there's growing evidence that might be beneficial for neurocognitive development of infants. And omega-3s are also a big topic of interest, really making sure that you get adequate fatty fish. And so I think the diet doesn't dramatically change, but there are key nutrients that become a little bit more important during pregnancy than they would be if you in the non-pregnant state. And that we want to make sure that you shift your dietary pattern to eat enough, not gain excessively, and also meet those key micronutrients. I think there's a lot of concern nowadays with very generalized, like, oh, plant-based diets are amazing for chronic disease, and that's great, but that gets translated into pregnancy, and it's like, oh no, foods like salmon and even a little bit of red meat become sources of really key nutrients during pregnancy that you're eating for optimal baby development, not about just 9 months. You don't need to eat for chronic disease risk reduction of something that's going to happen 35 years later. So I think there's often a mistranslation of general population-wide chronic disease evidence to these like key life stages where nutrient requirements change as we age. There's different times in your life where you may have to focus more or less on something. It is this dynamic process. It's not like there's one diet that fits babies, toddlers, adolescents, pregnant women, lactating women. And so a lot of nutrition science is really trying to figure out as we grow and adapt and develop and then age or enter different reproductive life stages, how do nutrient requirements change? And while the general diet can look similarly, there might be emphases that are placed on certain foods across that.
And it's interesting you mentioned this because we were almost denigrating supplements earlier when they're not indicated. But pregnancy is one of those times that certainly in medicine, we strongly advocate that women receive folate supplementation and also iron supplementation, particularly because we know that low levels of folate are associated with neural tube defects. And by that, we often talk about spina bifida. Essentially, the spinal canal doesn't close properly. There's brain and spine malformation. Certainly in medicine, we strongly advocate that folate is one of those key micronutrients that we see bad things happen when there isn't enough of it in pregnancy. I'm interested in choline.
On that point, before we deviate from it too far, it's that neural tube that we're trying to prevent spina bifida or in severe cases anencephaly from inadequate folate. Like that happens in the first trimester before most women know they're pregnant, really in the first month or so. So it's that folate messaging is really around the non-pregnant women, making sure that they go in and have adequate folic acid supplementation. So that recommendation is really strong for women of reproductive age to be getting folic acid in the diet, because by the time most women know they're pregnant, they have already missed that window. And so this is a perfect example of how like development is dynamic and certain nutrients are really important at certain time points.
It's for that reason that we've put folate into most bread in Australia, and we've folate supplemented nationally. The white bread in Australia has higher than natural levels of folate in it, which has been a really interesting public health campaign that's been quite successful. I wonder though, a lot of your research has been on choline. Can you what is choline? Like, what is it? Where do we get it? What food does it come in? Why should I care? Do I even need to care? Because I've read a lot of your papers, and a lot of it's focused on choline. You've even been to other countries, and in Sub-Sahara, you've looked at the role of choline in fetal development in pregnant women.
Yeah, so actually my Tanzania study is focused on B12, although we might look at choline biomarkers a little bit in it too, but they're related nutrients metabolically and supporting each other. But choline is it's not a vitamin, it's not a classical vitamin, and it's one of the last compounds that got the stamp of quote unquote essential nutrient. And so it was from originally a study done in men in 1991, because men are more susceptible to choline deficiency symptoms. And so the study done in 1991 was largely the basis for establishing nutrient intake recommendation values in 1998, and there was only a little bit of data in patients on chronic IV nutrition that we call total parenteral nutrition, which is free of choline, that sort of people who are on it long term essentially become choline deficient, and that added to the evidence saying this is probably an essential nutrient in humans. But so in the 1998 values, they only had studies in men and these patients who have like chronic GI issues that are not really indicative of the normal population. So it was really that study in men that was used to derive the recommendation for women and pregnant women. It was just guessing at these numbers. So studies talk about patriarchy, like studies in men were used to develop the values that we recommend for women and pregnant women. And it's like a great area to do your PhD and research in, because we are just like, we don't have very much data on choline and pregnancy in humans, but in rodent models, it was suggested that there's lots of evidence that choline in amounts excessive of the amounts in the diet that are required to make male rodents from being like quote unquote choline deficient are actually beneficial for the fetus's septohippocampal, so their brain development and the circuitry that's laid down there, and then postnatally their cognitive development, cognitive functioning. And so that was like really enticing rodent model research, but you have to translate that to humans. And some of our work has been supplementing choline at levels higher than would typically be in the diet and thought to be the quote unquote requirement, and just to maintain physiological function and the benefits that might have for infant brain development. And so I did some of this work with my PhD advisor, Marie Caudle at Cornell, who's a real leader in that world, and have continued doing pregnancy nutrition stuff since. But choline, the reasons it's beneficial is it gets incorporated into a phospholipid that's structurally important in all of our cell membranes. If you think you're growing a new fetus, you probably have to grow a lot of new cell membranes, and so there might be a strain on that nutrient. It's also a precursor to a major neurotransmitter, acetylcholine, and so that is important in just coordinating brain development and brain processes. And it's also a major source of things that we call methyl donors, that these methyl groups that it donates, and this is where folate is like a carrier for these methyl groups, and choline is a major source of them. So there's an interaction between choline and folate metabolically, but those methyl groups actually, they're used for many things in the body, like hundreds of reactions ultimately methylate substrate and turn it into a different product. And that, back to what we said in the beginning, metabolism, just taking one thing and converting it into another. One of the ways we do that is by adding a methyl group, which is just like carbon and 3 hydrogens. But those methyl groups also are tagging the DNA and the histones, which are the protein that DNA is wrapped around. And that process is particularly sensitive early on in fetal development. So your body's laying down the sort of what we call like an epigenetic code. And so the methylation state of your DNA, that later on all of your cells will just propagate as cells divide. But the pattern that you're going to have in your life, a lot of it is laid down early in pregnancy. So we think that choline is particularly, and the supply of choline is particularly important during development and pregnancy, because it's providing those methyl groups.
But what foods does choline come from?
Yeah, so it is largely concentrated within animal products. So it's really rich in eggs and egg yolk. And so you can think, just like we need a lot of choline to grow a baby chicken needs a lot of choline to make all of its cell membranes too. So there's some sort of cross kingdom overlap there, but you're cross species. But yeah, eggs are the major source of it. You get small amounts in a lot of foods. Milk ends up being a major contributor for folks, largely because we drink a lot of dairy, not because it's like super, super rich in it. And then you'll get things that you get in animal meats. It's particularly high in liver, but we don't recommend that during pregnancy because it also comes with preformed vitamin A, which can be toxic and be very detrimental to fetal development. But things like red meat have a little bit of choline in it. And then vegetables, you have to be careful when you look at, if you go Google the choline content of foods, people will tell you like, oh, there's a lot in broccoli, but it's okay. You have to eat a lot of broccoli to get to that 100-gram serving size that they're citing there. So it can run lower in vegetarian diets. And just the modern diet doesn't provide a ton of it, which is why it's currently easy to do studies in this because you can do a supplement and be pretty confident that everybody's diet in the background is relatively low, unlike something like an omega-3 where people have various amounts in their body because they have various amounts in their diet depending on the types that they eat from plants and animals. And that literature gets much messier because the background intake when you enroll in the study is so variable. So just randomizing somebody to an omega-3 is tough. And then, but with choline, people have typically between 200 and 400 milligrams of intake per day. And the supplementation levels that we use in studies are about 500 to 550 milligrams. So almost everybody is like doubling their intakes.
I just thought while we're talking about pregnancy, we should mention alcohol. We have a major public health campaign in Australia at the moment, very much, and there's great ads. I think they're very effective ads, but they're couples that are aiming to have children to stop drinking alcohol while they're trying, as well as during pregnancy. And I was just thinking we should mention the role of what we drink as well as what we eat in terms of our overall health and well-being, both out your thoughts on alcohol, but also on sweet drinks, or what we call soft drinks. I think you call them sodas in the States.
Yeah. So alcohol is definitely one that I think most obstetrics groups all recommend to minimize as much as possible. I know there's a lot of stress about this at the same time of women like thinking they had like half a glass of wine and they just ruin their baby's brain health. It doesn't work that way. It is very much a dose dependent thing. But we can't put like a recommendation for a safe level, like what's the lowest amount you can drink and not have negative effects of it. And so the recommendation is really just to abstain as much as possible for protecting that infant brain development. And too much alcohol can cause depletion of other nutrients like folate that are important too. So there's a lot of reasons not to do too much alcohol. There's actually high rates of drinking in certain places in the world, like in South Africa. And so people have done choline supplementation studies because choline has those neurocognitive benefits just for the general population. And it's been studied in rodents and in a couple of human trials in areas where rates of drinking are much higher and it's culturally more normative. So you can ethically do those studies. In the US, you couldn't go out and recruit people who are high drinkers and randomize them to choline because it would be seen as like overseeing a known detrimental exposure. But in places like in parts of South Africa, it's just culturally very normal to drink during pregnancy. And choline does buffer against some of the negative effects of alcohol on neurocognitive development. So all these nutrients start to interact at kind of some point, but that's not a reason. Do not start drinking alcohol and then
and supplements go and
choline.
We're talking about alcohol. We're really worried about like the big name fetal alcohol syndrome, where children are born with. Oftentimes, there's a specific facial feature, a receding forehead, a slightly misshaped cranial structure, skull structure, but we're talking about significant intellectual disability and cognitive impairment, which is the big worry with fetal alcohol syndrome. Propensity towards less intellectual sort of capacity means more emotional outbursts, means more aggression and violence. And it's a real issue in some communities. And while we're talking about sort of things that can harm, it reminds me of one of my colleagues who did a lot of work in Nigeria, where there's a significant issue with heavy metal toxicity and lead poisoning, because hundreds of communities are involved in mining. And the mining process essentially unearths a lot of lead, and that lead then poisons the local farms and water sources and is absorbed into the food. And high levels of lead toxicity lead to, not just in pregnancy, but in the general population, increasing rates of intellectual disability, increasing rates of violence and aggression. And so there's this sort of vicious cycle where entire communities become more aggressive and essentially less intelligent and less able to understand the impact that this negative practice is having on them. And it's a vicious cycle that then continues because it's very hard to intervene in a community where you've got, and I'm talking entire communities where the intellectual sort of capacity of a group of people has significantly dropped because of such high levels of toxicity. And it just comes back to, Kevin, what you were saying about the important role of regulation and the fact that we often don't know what's going on. I don't have the ability to control if the place where I get my broccoli is a farm that has essentially been exposed to high and toxic levels of heavy metals and incredibly high levels of zinc and mercury and lithium and lead, all these things which in tiny little doses are fine. I was really interested what you talked about the sort of using your muscle like a bit of a lever, the exposure to tiny amounts of toxins in plants, which when you mention it makes perfect sense because there's lethal alkaloids in apple seeds. No one's dying from eating an apple a day. So
Yeah.
insert doctor joke. Yeah, Julie, what do you think?
What I really want, if I could, is just one more question because our time is almost up. But here in Australia at the moment, we've got quite a significant discussion going about the um, worldwide problem of an increase in people under 50 being diagnosed with bowel cancer. But evidently, some research has come out indicating that Australia has the highest rate of people under 50 getting bowel cancer. And so I just thought it was an opportunity while we had to say, as I understand, they're not sure what is the driver. It may be obesity, it may be more processed food. But I suppose your reflections on that and any broad advice until we discover what may be happening, broad advice on diet for people under 50.
Yeah.
Avoid bowel cancer specifically, obviously.
Yeah, so I think that what you said, that we don't know the cause. Right now there's some early data coming out that looks like there might be changes in the microbiome that have contributed to this, and what the upstream causes of those changes are not clear, but they might be contributing. And so there's been some thought that it is due to the amount of fiber within the diet being much lower. Although fiber rates intakes have stayed relatively similar, so it's not clear if maybe fiber is just protective against something else that is really the driver of this. So lots of research to unpack there, but I always refer back to the American Institute of Cancer Research and the World Cancer Research Fund. The AICR, WCRF reports come out, and they are these broad, systematic reviews of everything we know about all diet and cancer. And so there are some high-level principles of eating pretty high fiber diets, with the fiber coming from grains and fruits and vegetables and legumes and nuts and seeds for the most part. And then actually high dairy tends to be protective against colorectal cancer. And so we think that calcium through a number of mechanisms might be protective. And then lower red meat diets tend to be associated, particularly processed red meats that are cured with nitrates, very high in sodium, etc. Like lowering the intakes of those are the kind of the core, in addition to maintaining a healthy body weight. So obesity is a likely big driver of this. And accounting for obesity in epidemiological studies it's often you have like a single BMI time point that doesn't capture the dynamics of body weight across a lifetime. And so I think most folks think that obesity is like a major driver of this. And the reason it doesn't fully explain it in statistical models is because we don't actually measure it but that there might be these other nutritional contributors to it as well. And it could be other things that we don't know yet. So I think stay tuned on the research front, but I encourage folks not to go run out and buy supplements or change crazy diets, because people often use this fear around, oh, young people are dying of colorectal cancer, to argue for doing all sorts of things that have no evidence. We have a lot of restrictive cohort data that's followed up people for a long time, asked about their diets at multiple points, and highlights these few key things like high dairy, high vegetable fiber intake, and lower processed meats as being major cornerstones, in addition to physical activity and maintaining a healthy body weight. So focus on, that's 5 things that should give people plenty to do.
And before I hand over to Aidan to take us out, I wonder if you could, because we've mentioned the microbiome twice, and you said it's commonly misunderstood and referred to in an unhelpful general way in social media. What's a brief, plain English definition of the microbiome and why it matters?
Yeah, so the microbiome, it technically refers to the microorganisms in any part of your body. I think it's been conflated with what is in the gut, but you technically have a skin microbiome, and there's microbiomes being described all over. But with the gut microbiome, it's something that a lot of those things are anaerobic and have been very hard to grow. But with modern sequencing technologies, you can much more readily identify all the bugs that are there, who's there, what genes they have, et cetera. So that's why there's been this explosion in our technology with DNA sequencing has allowed us to understand who's in our gut more than we ever did 20 years ago. And so there's a ton of research, but I think one takeaway with the microbiome is that saying something affects the microbiome isn't a health outcome on its own. If you're having GI pain or distress or cancer, or you're worried about cancer risk, you should ask, what is the impact of that diet, that supplement, that lifestyle change on the actual thing you care about? So if you have excessive bloating or gas, that's what you should be talking about. The microbiome might be the mediator there. It might be the thing that is causing it. But at the end of the day, focusing on, does this impact my microbiome, is like it doesn't matter if it impacts your microbiome. The microbiome is not a clinical thing. We can't look at your microbiome and predict anything all that accurately from it. And so it's much in the same way where people will get hung up on like a biomarker. Oh, this nutritional study said that higher seed oils impact like this oxidative stress biomarker. And people then take that and say that should be bad. And all the data on seed oils actually says that it's reducing chronic disease risk. So whatever it's doing that biomarker probably doesn't matter, or it's offset by something else. And so that sort of intermediate endpoint with limited ability to predict what's actually happening on the clinical things you care about or quality of life or whatever, that's what the microbiome is right now. We can't measure it in any way, and there's many ways to measure it. There's who's there in relative amounts, who's there in absolute amounts, what genes they have, what genes are being expressed, what metabolites they produce. So when you say microbiome, this is like, to a researcher, many potential outcomes. It truly has no meaning intrinsically. But again, influencers survive on vagaries and sell you things based off of them too. And so if you have a problem you're concerned with, ask about that problem, not about what the microbiome is doing necessarily. The microbiome is kind of like a mechanism that you don't really need to focus on all that much. So I have a lot of patients who come talking about their microbiome, and I go, okay, but like, what symptoms are you experiencing? And like, I don't have any symptoms. And it's just kind of, okay, I can give you general things about fiber, but I can't like there's no evidence that I can supercharge your microbiome by changing anything that's going to prevent all the disease outcomes, because the microbiome is very poorly prognostic in predicting things like chronic disease.
I love this. In emergency medicine, there was a term that got thrown around a few years ago that sort of percolated through. We call it BSEs, bullshit surrogate endpoints. Because what we care about is who lives and dies, what's their quality of life, do they have pain or do they have symptoms? We don't care about whether someone's blood pressure went a little bit higher or a little bit lower. The research has to focus on, is the person living a good quality of life? Are they healthy and are they happy with how they're living? Not focusing on symptoms, right? Not this protein was expressed slightly higher, this protein was expressed. That's the starting point for our research, not the end of our research. We start with, let's have a look at patterns and find what is expressed more and less and measure levels and target certain things. And then we see, does this actually help people? So I love that message. I love that message.
I always tell folks like the mainline drug for type 2 diabetes is metformin for the most part. And metformin works. It lowers blood glucose. It helps with glycemic control. We know that. Which protein it acts on in the body, the things it changes. There is about 15 mechanisms that have been put forth that it's working in the gut, it's working in the liver, it's working in the muscle, it's working through mechanism X, Y, Z. At some point, I mean, that's important for reasons that researchers care about, but clinically, it doesn't matter if it's activating FXR in your gut or it's activating cyclic AMP signaling in your liver, and all these things have been put forth. That's kind of what the microbiome is for me. Saying it's the microbiome as being like, oh, the metformin's acting on cyclic AMP in the liver. I'm like, okay, but does it lower your HbA1c or not? Does it reduce cardiovascular disease events or not? And so I think shifting the focus, because this is as people navigate the sort of social media environment, people are almost always fed a mechanism and not the clinical endpoint. You should take this because it activates autophagy, and autophagy is amazing for all these reasons and it's supposed to make you live longer. But then you ask, okay, but has that been proven to make me live longer? And people are like, no, but it activates autophagy. So it's a lot of conditional statements that are built in, I think, in computer programming a lot. So it's if-then statements that are happening. And many of the claims out there are just series of if-then statements that have so many contingencies and assumptions built into them, and no actual evidence. Like, they're like, if A affects B and B does C and C does D, and then you'll get to Z. And it's, nope, that's just, does A influence Z or not? That's what we need to focus on. And all the steps in between don't really matter that much to the patient. And so there's a lot of hype in nutrition and supplements on it affects whatever. I'm currently just in the news here. There was something about plasma exchange that people are doing in these sort of biohacker clinics, and it influencing epigenetic clocks. And they measured 36 different epigenetic clocks, and it impacted some and not others. So what does that even mean? No one who's honest can really tell you, but they will try and sell you total plasma exchange from it. And I know people get tired of saying we need more research on these things, but we have a core guidelines that are summarized by expert panels that get together and grade all the evidence and say, this is what's likely to matter, this is what needs more research, this is what has no research. And we put out messages of what the things, high-level things to focus on that we know are going to be impactful. There is some legitimate gray area, but that I think people need to be, true informed consent is having that gray area. People telling people that's gray area.
Amazing. Look, Kevin, I think we'll probably wrap up there. Thank you so much for coming on today. Julie and I are beaming. We are so happy to have someone able to untangle the web of misinformation in nutrition. It's been awesome hearing from you. If people want to follow your work, they can look up Kevin C. Klatt on Google, Klatt. Dr. Klatt has got some fantastic online blogs and Substacks and is on Twitter. As far as Julie and I are concerned, remember to take your medicine as prescribed. Have a fantastic week, everyone, and tune in for next episode of This Might Sting. Thank you so much.
This Might Sting is hosted by Aidan Barron and Julie McCrossan. Executive produced by Joshua Kirsch. While we always work to give you the best information and tips, nothing in This Might Sting should be construed as personal healthcare advice. You should always make health decisions in consultation with your general practitioner and specialists. If you'd like to hear us talk about a topic on the show, or if you think we've made a mistake and want to request a correction, please contact us at questions@thismightsting.com.au.